students, today in this module we will be discussing about hazardous waste with special emphasis on treatment and disposal. As I told you earlier, in the module number 12, which deals with hazardous waste, we discussed about the definition of hazardous waste, then we discussed about the various characteristics based on which they are categorized as hazardous waste. Then we also discussed about its collection, storage, collection containers and the segregation methods. Now in this module, we will be focusing on treatment and disposal. Now, what are hazardous waste? Now, hazardous waste are a category of solid waste which possess certain characteristics based on which they are separated and categorized under a special category called as hazardous waste. Now, what are these characteristics? They are the corrosivity, reactivity, ignitability and toxicity. I am sure you are aware of all these things which we have discussed in the last class. Now, with this introduction, now let us get into the learning objectives. Now, the learning objectives of this module include: you will gain knowledge on the various physical, chemical, thermal and biological treatment methods which are available for the hazardous waste. Then, you will understand what is the concept of landfill with special focus on hazardous waste. Now, how do you contain the hazardous waste? That we will study. Then, you will also familiarize about the different alternate disposal options that are available for the hazardous waste. Now, let us talk about the treatment and disposal of hazardous waste. Now, hazardous waste reduction and minimization. Now, hazardous waste require certain special control procedures. Now, you need to have an effective identification and labeling of waste, which if it is done by the generator, it will be very easy for us to have or abide by the manifest based system. Now, the management of hazardous waste generally implies certain considerations for alternate methods and schemes, which would be both institutional and technical to hazardous waste reduction. Now, there are certain important measures which you have to adopt as part of your hazardous waste reduction and minimization measures. Now, what are they? One is your elimination, second would be your reduction, third would be your recycling, fourth is treatment to reduce their volume and toxicity. Now, what is elimination? Elimination is nothing but this is of prime importance. Like before certain hazardous substances being produced, try to find out certain ways so that you can eliminate the use of these hazardous substances. So, the prime priority is to find out ways to eliminate and use certain other alternate materials so that you can avoid the generation of hazardous substances. Now, this elimination might be achieved by changing or bringing in small changes in the manufacturing process or by substituting products that can satisfy the same need without creating any hazardous waste. For example, you can use these concrete posts in place of creosote treated wooden post. This is one example. The second step in the hazardous waste reduction measure is your reduction. Now, this is the next priority after elimination. Now, if you cannot eliminate something, you can reduce the amount of hazardous waste that is being generated. So, again, if you bring certain changes in the manufacturing process, you can modify and yield a substantial waste reduction. Example, you can bring certain changes in the chemical reaction conditions which can minimize the production of the byproduct hazardous substances. In some instances, the potential hazardous catalyst can be replaced by catalysts that are non-hazardous or which can be recycled rather than discarded. So, this can be one simple or small measure which you can take to avoid or reduce the hazardous waste generation. The third one is your recycling. The third strategy is to recycle the hazardous waste, like your solvents, acids which are being used at the larger scale can be reused by doing certain minimum treatment and by recycling. So, there are many industrial processes that uses solvents. Now, these solvents can be recycled by certain methods and you can reuse them. Now, this will also save cost and also avoid pollution. A number of operation methods can be used to purify the solvent. Now, you can use the entrained solids can be removed by settling, filtration or centrifugation. Now, drying agents can be used to remove the water that is present in the solvent. You can go for a fractional distillation and separate solvent from impurities and water and other solvents. Now, finally, the hazardous waste can be treated to reduce their volume and toxicity. Now, elimination, reduction and recycling reduces the treatment and disposal cost, and often the generator can find it best because it is economically viable and it is cheap also. If a person is doing all these things, he can reduce the cost of operation. Now, let us discuss about the various hazardous waste treatment technologies. Now, broadly if you see, the treatment technologies can be categorized as a physical treatment technology, chemical treatment technology, thermal treatment technology and biological treatment technology. Now, the selection of a treatment process will depend upon the waste stream. Two major factors are very important. One is the nature of waste and second one is a characteristic that you require in an output stream. That is, after treatment, what is the characteristic that you are expecting from the waste. Now, even after rigorous hazardous waste reduction programs, still you have generation of large quantity of waste which require treatment, and that is why we propose certain treatment technologies. Now, as I told you earlier, you have different treatment technologies like your physical, chemical, biological, thermal or stabilization and fixation. Now, let us discuss one by one. Now, the physical treatment methods. Now, physical treatment methods, you have different types of methods starting from your adsorption, distillation, filtration, reverse osmosis, resin adsorption, so on. So, we will discuss each one in detail. Now, first adsorption. Now, adsorption on activated carbon generally occurs when a molecule is brought up to its surface and it is generally held by physical or chemical forces. Now, this process will be generally reversible and you can regenerate the material which you are using. Like the activated carbon which is used as an adsorbent can be reused by applying many different chemical treatment and you can reuse it again. Now, these chemical treatment would be heat, steam or solvent treatment. Now, if the concentration of the adsorbed species is high enough and the material is biodegradable and non-toxic to the bacteria, then the biological activity may significantly increase the effective removal capacity. Now, the removal through adsorption of activated carbon has been applied to a number of non-aqueous waste streams like your petroleum fractionation, syrups, vegetable oils and pharmaceutical preparations. Now, what are the factors which influence this process or the adsorption capacity? One, greater the surface area, greater would be the adsorption capacity. For example, activated carbon that has a large surface area will obviously have higher adsorptive capacity. The adsorptivity increases as the solubility of the solute decreases. For hydrocarbons, the adsorption increases with molecular weight. Now, for solutes with ionizable groups, the maximum adsorption can be achieved only when the pH is corresponding to the minimum ionization. Now, adsorption capacity once again decreases with increasing temperature. The second type of physical treatment method is your resin adsorption. Now, waste treatment by resin involves two basic steps. One, contacting the liquid waste stream with resin and allowing its adsorption from the solution. Now, second one would be subsequently regenerate the resins. Just like your activated carbon, the resin should be regenerated by removing the adsorbed chemicals by either simple washing with proper solvent, or you can also go for certain other treatments. The adsorption of these non-polar molecule onto a hydrophobic resin will generally result from the effect of the van der Waals forces. In certain other cases, other type of interactions such as your dipole-dipole interaction, hydrogen bonding should also be considered because they also play an important role. In certain cases, if you see, like example, if you take an ion exchange mechanism, this is involved. Now, the third one is your sedimentation. Sedimentation again is one physical process where your particles which are suspended in a liquid are allowed to settle down depending upon the gravity. Now, the sedimentation can be done either in the batch process or a continuous process. The continuous process technique are widely used for removal of heavy metals from iron and steel industry, removal of fluoride from aluminum production wastewater, heavy metals from wastewater that are generated from copper smelting and metal finishing industries. Also, you can remove organic chemicals from the wastewater stream using this method. Now, what are the process requirement? You need a basin or a container of a certain size so that you maintain the liquid that is to be treated in a relatively quiescent state for a specified period of time. Now, also you give a means of directing the liquid to be treated in the container in a manner so that it settles down. What I mean to say is, when you add the liquid into the container, you give it in a certain way that it does not disturb the settling process and you slowly keep adding it. Also, you find a certain way of removing the solid which has been settled from the liquid. The next type of physical treatment method is your electrodialysis. The electrodialysis involves the separation of an aqueous stream from a depleted stream. Now, what is an aqueous stream? Aqueous stream is nothing but the concentrated solution or electrolyte that is original. Now, success of the process will generally depend on the special synthetic membrane which is used. Now, this synthetic membrane will be generally permeable only to one single type of ion. Now, the feed water is generally passed through compartments formed by the spaces between alternating cation and anion permeable membranes which are held in a stack. At the end of each stack, you can have an electrode having the same area as that of the membrane. Now, a DC potential will be applied across the stack which causes positive and the negative ions to migrate in the opposite direction. Now, this technique is generally used for desalination of brackish water. The other technique is your reverse osmosis. Again, this technique is popularly used in recent times and it involves a membrane which is a semi-permeable membrane that is permeable to solvent but impermeable to the dissolved species, be it organic or inorganic. Now, these devices generally use pressure. They are pressure based mechanisms or removal systems, and the device uses pressure to force the contaminated water against the semi-permeable membrane. Now, the membrane generally acts like a filter and it allows only the water. Now, water is forcefully pushed through the pores, but it restricts the passage of large molecules which is generally removed as a reject. Now, the cellulose acetate membrane, polysulfones, polyamides are the different types of membrane which are generally used in a reverse osmosis process. Due to the susceptibility of membranes to chemical attack, fouling and plugging of the flow system and erosion problems, the feed water is generally pre-processed and then subjected to the reverse osmosis process. The next one is a solvent extraction. Now, solvent extraction is a separation process where the constituents of a liquid solution is removed by contact with another immiscible liquid. The substances comprising of the original solution distribute themselves between two liquid phases and a degree of separation occurs between them, and that is how the treatment process takes place. Now, the efficiency of separation will increase by multiple contacts. Now, the major application of solvent extraction to waste treatment is the removal of phenol from byproduct wastewater produced from coal, coking, petrol refining and chemical synthesis that generally involves phenol. Now, they also use supercritical fluids, example your carbon dioxide which is used as an extraction solvent. They are also being used and it is considered as one of the promising approach in solvent extraction. Now, fluids existing at or above the lowest temperature at which condensation may occur can be generally used for this extraction process. Now, distillation. Distillation is again an expensive and energy intensive process and can probably be justified only when you use or when you want to recover certain valuable products like your solvent recovery. Now, this technique has only limited application in the treatment of dilute aqueous hazardous waste. Next is evaporation. Now, evaporation process is used for treatment of hazardous waste like your radioactive liquids and sludges and the concentrating plate and paint solvent waste. Now, it is capable of handling liquids, slurries and sometimes sludges. Now, sludge can be both organic, inorganic and it can contain suspended or dissolved solids or dissolved liquids. Now, at least one of the components which you are using should be non-volatile. Now, it can be used to reduce waste volume prior to landfill disposal or incineration. Now, what is the disadvantage of this process is like they are very costly and they involve a high capital and operating cost. Also, they require a high amount of energy. Now, this process is more adaptable to wastewater that contain a high concentration of pollutants. Now, filtration is the next type of physical treatment method, and it is well developed and it is an economical process when you use it in a full scale treatment of industrial wastewater and waste sludges. Now, the energy requirement for this process is very low and operational parameters are well defined. But this filtration process is not used as a primary treatment process, and it is generally used in association with other processes like precipitation, flocculation, sedimentation and so on. Now, flocculation is a process where you use inorganic flocculants like alum, ferric chloride and so on. You might have heard like in your house, when you have a well which is having a lot of mud or suspended materials, you generally add alum and then flocculate the materials and then purify the water. The same thing is applied here also. Now, the alum will be mixed with water, and at a slightly higher pH, it will hydrolyze the hazardous waste and form a gelatinous precipitate called as the aluminum hydroxide. Now, the alum, due to its large surface area, they are unable to entangle the small particles due to the large surface area. Hence, the flocculation is just a partial action. Now, on flocculation of these suspended particles into larger ones, then you allow them to settle down and the suspended particles which is flocculated will be removed by sedimentation process. Generally, the separation takes place based on the density difference that exists between the suspended matter and the liquid. Now, let us discuss about certain chemical treatment methods. The first chemical treatment method is your chemical oxidation and reduction. Now, oxidation reduction is one important route which is used for treatment of hazardous waste. Now, it is a process by which the hazardous waste are converted into a form so that it shows reduced or no toxicity, reduced or no mobility, and generally it remains inert. Now, the process can be a short or a medium term technology, and it can use certain oxidizing agents like your potassium permanganate and dichromate and so on. Now, chlorine in alkali solution is used to convert cyanide to cyanate, which is a less toxic form. More addition of chlorine oxidizes the cyanate to carbon dioxide and molecular nitrogen. Now, the equations are given below. You have sodium cyanide, you add chlorine and NaOH, which will give you sodium cyanate, sodium chloride and water. Same way, once again sodium cyanide can be treated with more amount of chlorine, and under the condition of NaOH, it will get oxidized or mineralized to carbon dioxide, molecular nitrogen, sodium chloride and water. Now, likewise, the hexavalent chromium, which is a toxic form, can be reduced to trivalent chromium by using sulfur dioxide as reducing agent. Now, 3 molecules of SO2 will react with 3 H2O and it will give 3 H2SO3, and this will react with 2 molecules of CrO3 and it will give Cr2SO4 thrice and 3 molecules of water. Likewise, you can oxidize iron and precipitate them as ferric hydroxide. 4Fe2 plus O2 plus 10 H2O will give you 4Fe OH thrice plus 8 H plus ions. Now, sulfur dioxide can be further oxidized to sulfuric acid. 2SO2 plus O2 plus 2 H2O will give you 2 H2SO4. The next process is your ozonolysis. Here, the ozone is used as an oxidizing agent which has a potential to oxidize a wide variety of contaminants that are present in the wastewater and sludge. Now, they are generated by electrical discharge through dry air or oxygen. Now, TCDD demonstrated that if the dioxins were suspended as an aerosol in combination with carbon tetrachloride, you can obtain a degradation percentage of 97%. Now, the destruction of even PCBs, the polychlorinated phenols and pesticides can be done using ozone in conjunction with your UV radiation. In both the cases, the key requirements were to concentrate the TCDD in a medium and to make them susceptible to attack and provide a free radical for reaction with molecule. Next one is your acid-base neutralization. Now, a waste that is having a pH less than 2 or more than 12.5 are generally categorized as corrosive hazardous waste. Now, they can be neutralized by an acid-base reaction. Lime is a very good agent to neutralize the acid waste. Now, addition of the slaked lime to acidic waste in a continuous stirred chemical reactor will result in neutralization of hazardous waste. Now, certain alkaline wastes are also neutralized when you bubble gaseous carbon dioxide forming carbonic acid. In addition to this, you can also do certain waste treatment process which require prior pH adjustment. Now, the process will include generally oxidation reduction, adsorption, wet air oxidation, ion exchange, stripping and biochemical treatment. The next process is your chemical precipitation. Now, precipitation is applicable for mixed waste. I mean when you contain both organic and inorganic species. Now, by this method, the toxic substances or metals can be precipitated using chemicals and they can be removed from solution by sedimentation or settling or filtration. Now, alteration of solution pH will generally minimize the solubilization of heavy metals and it can be further precipitatable hazardous constituent. Now, generally slaked lime or caustic soda is used for precipitation of metal ions as metal hydroxides. Now, these are certain equations which shows your chemical precipitation process where your lime is used to precipitate the metal as hydroxide. Now, M2 plus CaOH twice will give you MOH twice plus calcium ions. Now, same way if you want to precipitate chromium, chromium can be precipitated as hydroxide. So, Cr3 plus 3 molecules of hydroxyl radicals will give you CrOH thrice. Same way carbonate ion hydrolysis in water to give hydroxide ion. Now, CO3 2 minus plus H2O will give you bicarbonate plus hydroxyl radical. Now, sodium borohydrate is another reducing agent which can be used to precipitate metal in the elemental form. One example is given below where 4Cu2 plus NaBH4 plus 2H2O will give you 4Cu plus NaBO2 plus 8H plus. The next process is hydrolysis. Now, hydrolysis treatment can be given to those hazardous waste constituents which shows really high reactivity with water. Examples can be your halides, carbides, hydrides, alkoxides and other active metals. Now, examples are given in terms of equation where SiCl4 plus 2H2O gives SiO2 plus 4HCl. Same way CaC2 when it reacts with water it gives calcium hydroxide plus C2H2. NaAlH4 plus 4H2O will give you 4H2 plus NaOH plus AlOH thrice. NaOC2H5 plus H2O will give you NaOH plus C2H5OH. Calcium reacts with 2 molecules of H2O to give calcium hydroxide and H2. The next process is your ion exchange. Now, ion exchange is best suited for wastes that have undergone pretreatment or minimum treatment with other chemical and physical methods. Now, they are suitable for removing inorganic chemical species which are in the dissolved form unlike your precipitation, flocculation or sedimentation. Now, it is used as a final polishing step to reduce the inorganic species that could not be reduced to a satisfactory level by other chemical treatment methods which we have seen so far. Now, nickel cyanide complex and chromate ions from hazardous waste solutions are generally removed by anion-ion exchanges. Now, ion exchange resins have been used in the removal of radionuclides from radioactive waste. The equation is given below. Now, in the first part of this module, we discussed about the hazardous waste reduction methods where we discussed about elimination, reduction, recycling and volume reduction. And then we discussed about various physical methods and various chemical methods. Now, in this part, we will be discussing about the thermal treatment methods, the biological treatment methods and the disposal options which are available for the hazardous waste. Now, thermal treatment methods are methods where the waste is thermally destructed by process of incineration and pyrolysis. Now, incineration is a process where the waste is combusted at a very high temperature of 900 to 1100 degrees Celsius in the presence of oxygen. Now, generally it converts the waste into an inert and less toxic material which remains less bulky, which is generally the ash. Incineration process reduces the volume of waste by 90%. The organic elements such as carbon, hydrogen and oxygen are converted wholly or partially to certain gaseous forms. Now what are these gases? It is generally carbon dioxide, water vapor and ash. Now what are the advantages of incineration? Now as I told you earlier, they reduces 90% of volume of waste. It can be scaled to handle large volume of liquid waste, and it is considered as one of the best method for treating mixed waste and other biological hazardous waste like your biomedical waste. Now they also do not require a large area of land. Now what are the disadvantages of incineration? One, it involves a high capital and operation cost. Second one is the ash, because they have to be disposed properly. Now the gaseous and the particulate products of combustion should be controlled by the air pollution control devices. Now the next thermal method is your wet air oxidation. Now wet air oxidation is a process by which the dissolved or the suspended organic substances are oxidized in an aqueous phase at a very high temperature and pressure of 150 to 325 degrees Celsius and a pressure of 2000 to 20,000 kilopascals. Water acts like a catalyzing agent and moderator, and it removes excess heat in the reaction mixture. Now water also acts like an excellent heat transfer medium, so that the wet air oxidation process becomes thermally self-sustaining at a very low organic feed conditions. Now in wet air oxidation, the waste is pumped into the system through a heat exchanger into the reactor with high pressure pump and will be mixed with air from an air compressor. Now high pressure generally facilitates the oxygen to dissolve in water. Sometimes the oxidation is carried out in the presence of certain catalyst. Example, the cyanide from the electroplating waste solutions are generally removed by wet air oxidation process. The equation is given below. 2Na plus 2Cn minus plus O2 will give you 2Na plus 2HCO3 minus plus 2NH3. The next process is your photolysis. Now in photolysis, light is used as an agent to cleave the chemical bonds in the hazardous waste material. The chemical species are excited by light and they are usually in a diradical state, because diradical generally possess a lot more energy to undergo chemical reaction. The success or effectiveness of the process will generally depend on the chemical structure of the compound, efficiency of radiation source and the medium in which the reaction is generally carried out. Now the end product also determines the efficiency of the process. Now PCBs, CDDs are generally destroyed by the photolysis process. Now there are three requirements of photolysis of TCDD. 1. Dissolution in a light transmitting film. 2. Presence of organic hydrogen odor. 3. Ultraviolet light. Generally, during photolysis reaction, the hydroxyl radical is formed, which plays an important role in chain reactions and results in the destruction of the compound. Now, let us look into the various biological treatment methods. Now, the biological processes are generally used because they are eco-friendly, they are cost effective and simple in nature. Now, their application to hazardous waste is generally limited because these hazardous wastes are toxic to the biological agents which are involved, like your bacteria, fungi, actinomycetes and so on. The biodegradability of the waste generally depends on the physical and chemical properties of the compound. Now, selection of an appropriate organism and optimum conditions will generally favor better degradation than your chemical methods. Example is your phenol and phenolic compounds, which can be generally treated if you properly acclimatize the biological agent to the hazardous waste. You can use both aerobic as well as anaerobic bacteria for treating the hazardous waste. Now, the presence of inorganic substances will generally limit the biodegradation of waste because they inhibit the enzymatic activity of the microorganisms. Further, they also get adsorbed onto the microbial cell coating. Now, during the process, H2S is generated, which precipitates toxic heavy metal ions as their respective sulfides. The overall degradation of the hypothetical organic compound, I mean the CH2O, is given by the following equation. Now, let us discuss about the land treatment. The application of waste to soil surface in a controlled manner is termed as your land treatment. Now, this process facilitates containment of waste followed by biological and chemical degradation. Now, this type of treatment is different from landfilling. Here, the soil is used to detoxify, immobilize and degrade all or a portion of the applied waste. Now, landfill contains the waste and it prevents the migration of any pollutant to the outside environmental matrices like your soil, air, water and so on. Now, a hazardous waste should not be placed in a land treatment site unless and until the waste can be made less hazardous or non-hazardous by the reactions which occur in the soil. The waste is added or mixed with the aerobic soil horizon in a controlled manner at certain appropriate conditions. Now, by doing so, the physical, chemical and biological characteristics of the waste will be altered. The bacteria, fungi and actinomycetes play a major role in land treatment. Now, waste like your petroleum refining, biodegradable organic chemical waste including your organochlorine compounds are generally suitable for land treatment. Now, land treatment should not be applied to waste which contain acids, bases, toxic inorganic compounds, salts, heavy metals and excessively soluble, volatile and flammable organic compounds. Now, we will discuss about the disposal options. One of the safe method of disposal of your hazardous waste is your landfills. Now, landfills, the structure wise if you see, it has a liner system at the bottom, waste emplacement where the way by which you load the waste, and the third one is your cover system. Now, these are the three different components of landfills. The details of these will be studying in the upcoming modules. Now, the liners as I told you, which is laid at the bottom and it will protect the soil and the penetration of these pollutant into the groundwater. They should be generally impermeable and they avoid the contact between the waste and the surrounding environment. Now, these liner system will also have a leachate collection system which will drain and also act like a leak detector, and it is an integral part of the landfill system. They generally ensure that the leachate does not leave the disposal site. Now, hazardous waste are contained in a secured landfills which are provided with a double liner system. Again, as I told you, you have two different types of landfills. One is sanitary and secure landfill. Sanitary landfills are generally used for municipal solid waste and secure landfills are used for your hazardous waste. Again, based on the liner system, secured because you have to provide more protection to the hazardous waste. So, you use generally a double liner system. Now, the liner system generally consists of clay, synthetic polymers and a leachate collection system. The primary barrier is a synthetic polymeric flexible membrane with a separation layer of thin geotextile or polymeric material like your HDPE, LDPE, PVC, etc. Now, the secondary barrier is composed of clay, bentonite enhanced soil or any other geosynthetic clay material. Now, the leachate collection tubes will be layered between the waste and the protection layer. Now, it will channelize the leachate to a pumping station where you can remove it and subject it to further treatment. An intermediate high permeability drainage layer is incorporated between a primary and secondary barrier of the double liner system. This layer is for the collection of leachate and gas. Now, every barrier is generally separated by a geotextile fabric. Now, the landfill is sloped to avoid infiltration of water and runoff which is associated with it. The leachate that is collected will be treated either by passing it through a column containing sorbent material like your carbon or fly ash, or you can subject it to suitable physical or other chemical treatment process. The secondary leachate collection system will generally act like a backup system which will be useful during the failure of your primary leachate system. Now, the continuous monitoring of groundwater wells should be done so that it will help you to determine if there is any failure in your primary and a secondary liner system. Now, waste is generally loaded inside the landfill after a preliminary treatment like your solidification, stabilization, etc. As I told you, the third component is your cover or capping, which is very essential to contain your waste in the landfill. The purpose of the landfill cover is to protect the waste, prevent entry of rain and surface water into the waste, control the release of landfill gas, to prevent ingress of air and enable the growth of short rooted plants when covered with the topsoil. Now, landfills are generally allowed with sufficient vent points so that if methane is generated, it may be burned off continuously. Now, this figure shows the schematic of a hazardous waste landfill. Now, so far whatever we have discussed, you can see here, you can see a liner system, leak detection system, and you have an impervious liner which is made of clay. Then you can see how your hazardous waste after a certain process like solidification and stabilization is placed inside the landfill. You can see these monitor wells like for the detection, leak detection of your liner system. Also on top you can see compacted clay cap. Also you can see these leachate drains which are present there. Now the alternate disposal options are, one is your surface impoundments and the second one is your deep well injections. The surface impoundments is a man-made excavation or a diked area which is done which can be either natural or topographic depression designed generally to hold or accumulate the liquid waste. The construction is just similar to that of your landfills, where the bottom walls function like a liner which is impermeable to liquids. The surface impoundments are also provided with certain provisions for collecting the leachate. Now, geological siting and selection of low permeable material like soil and clay are very, very important because they will arrest or minimize chances of pollution of groundwater. The other alternate option is your underground injection. Now, underground injection or deep well injection, it is a deep well disposal option where the hazardous waste materials are injected into the underground strata under pressure. Now, the underground strata must be generally impermeable and separated from the aquifers. Again, this is done to avoid pollution of your groundwater. Now, during this process, the chance of chemical reaction with waste constituent and mineral is possible. This will result in corrosion and clogging problems. The main concern with the underground injection is the potential for contaminating your underground drinking water supplies if the disposal well is not properly cased or if it is damaged. To summarize, at the end of this module, you must have gained knowledge about the different hazardous waste treatment technologies. We started off by looking into the various reduction and minimization measures like your elimination, reduction, recycling and reduction in the volume or toxicity. Then we started discussing about the different treatment methods like your physical treatment methods which involves your adsorption, resin adsorption, sedimentation, electrodialysis, filtration, distillation and so on. Then we discussed about the certain chemical treatment methods like your chemical oxidation, reduction, precipitation, flocculation, ion exchange, hydrolysis, ozonation, etc. Then we discussed about incineration and pyrolysis as part of your thermal destruction method. Finally, we discussed about the biological treatment method and disposal options like your landfill, land treatment and underground injection. I hope this module would be of help to you. Thank you.